discuss about the Helmholtz free energy. Helmholtz free energy, or it is also called as work function. The notation for Helmholtz free energy is A. Helmholtz free energy is a state function. Also, it is extensive property. Clear? Thermodynamic state of the system. That means Helmholtz free energy is a state function. It depends only on the thermodynamic state of the system. It is a extensive property. Helmholtz free energy is an important thermodynamic property used to find the maximum amount of work that can be obtainable from the system. Maximum amount of work that can be obtainable from the system. Okay. The formula to estimate the Helmholtz free energy is A is equal to U minus T into S. A stands for Helmholtz free energy, U stands for internal energy, T stands for system temperature, S stands for entropy. Clear? In differential form, I can write like this: del A is equal to del U minus del Ts. Or I can write like this: dA is equal to du minus dTs. Clear? So expansion of this equation, dA is equal to du minus T ds minus S into dt. The first law of thermodynamics says that internal energy, changes in internal energy is nothing but dq minus dw. This is obtained from first law of thermodynamics. Or I can write like this: dw is equal to P into dv. Clear? Second law of thermodynamics states that the ratio of changes in heat content divided by temperature is equal to entropy. Changes in entropy. Hence, I can write like this: dq is equal to temperature times the changes in entropy. dq is equal to temperature times changes in entropy. Okay. Now I can replace dq instead of tds. Hence, this equation becomes changes in Helmholtz free energy. dA is equal to du, instead of du, dq minus dw. Instead of dq, I am going to write tds. Instead of dw, I am going to write pdv. Hence, it is tds minus pdv. Again, tds minus pds minus s into dt. Alright? TDS gets cancelled. TDS gets cancelled. Remaining thing is changes in Helmholtz free energy is equal to minus PdV minus S into dt. Minus PdV into S into dt. Now I am going to fix a condition: reversible isothermal process. Now I am going to fix a condition for a reversible isothermal process. Reversible isothermal process. Since it is an isothermal process, dt is equal to 0. Then dA is equal to minus P into dV. Clear? or I am going to write like this. Del A is equal to PdV is nothing but W minus W. Since it is an isothermal process, I am going to write like this at constant temperature. See, isothermal is over. What is called the reversible? Reversible means it is a maximum amount of energy or work obtainable from energy. So this is called as work max. Clear? Work max. Okay. So this equation I am going to write like this: W max is equal to minus of del A constant temperature. For reversible process, the decrease in work function. For a reversible process, the decrease in work function is equal to the maximum amount of work that can be obtained from a system. For a reversible process, the decrease in work function is equal to the maximum amount of work that can be obtained from the system at constant temperature. Clear? This is the reversible isothermal process. Clear? So, Helmholtz free energy, knowledge on Helmholtz free energy is important, very much important in thermodynamics aspects. It is useful to find out the maximum amount of energy that can be converted into work, or maximum amount of work that can be obtained from the system at constant temperature. If it is a irreversible process, this equation becomes W irreversible is less than that of the changes in or decrease in Helmholtz free energy. Reversible process, this is the limit, maximum amount of work that can be obtained. For an irreversible process, definitely a lesser amount of work that can be obtained. So, W reversible process is less than that of decrease in Helmholtz free energy at constant temperature. This equation that means A is equal to U minus Ts leads to the application of what you call Maxwell's relation. Okay, this is isothermal. Now I am going to remove the isothermal concept. Come here. What is the equation? This one. This is the equation. Decrease in Helmholtz free energy is equal to minus P ds minus S into Td. Sorry, P dV, P minus P dV minus S into dt. Right. First process. And volume is constant. Now the equation becomes changes in Helmholtz free energy is equal to volume gets cancelled. Volume is constant, V is equal to constant, dV is equal to 0. Hence this equation becomes minus S into dt. I am going to differentiate the differential form of Helmholtz free energy with respect to temperature or constant volume. Now I am going to differentiate this dou A by dou T. Differentiation with respect to temperature at constant volume V is equal to minus S. Next, temperature is constant. Temperature is constant means T is equal to constant and dt is equal to 0. For an irreversible process. So this equation becomes changes in Helmholtz free energy is equal to T is equal to constant, dt is equal to 0. This equation becomes minus P into dt. Now I am going to differentiate this equation with respect to volume. Now I am going to differentiate this equation with respect to volume at constant temperature. So dou A divided by dou V at constant temperature is equal to minus P. For an irreversible process. Clear? This is the information regarding Helmholtz free energy. Helmholtz free energy or work function. It is a state function, extensive property. It depends mainly on the thermodynamic state of the system. It is extensive property independent of mass. Okay, it depends on mass. Extensive property, it depends on mass. This work function is very much useful in thermodynamic aspects in order to find the maximum amount of work that can be obtained from the system under reversible condition. For an irreversible condition, this maximum work, it is a limit for reversible process. In irreversible process, it will be less. This is the important information. Further, in next Gibbs free energy, this equation provides the Gibbs free energy. It will be concluded in the next class. Thank you.